Dear tandemPV friends, it's a pleasure for me to be with you today and moderate the second panel discussion. My name is Rok Drozowski. I'm Vice Chairman of tandemPV and CEO of IPVF, which is the French Energy Transition Institute, bringing together research teams from CNRS, École Polytechnique, EDF, Total, Air Liquide, and others to work together on next generation PV. We have gathered today 9 top-level speakers you have met over the last days around the following topic: what is essential, what is missing for tandemPV industrial implementation. In order to get balanced contribution within the 30-minute time slot we have, I will ask each of them to deliver a 3-minute statement shipping you their key messages. We believe this will give the audience a great overview on the opportunities and challenges ahead. So without any further ado, we will start with Solène Berson from Ines. Solène, if you will.
Yes, good afternoon. Thank you, Rok, for the introduction. So I think that we are part of CEA, so an RTO. So I will talk on the RTO side, and I think that we have seen this week that we have lot of work to do still in the lab and in the institute to make this tandem technology a real technology. We have, and this is at the material. On material aspects, not only the perovskite material, but we have seen that all the interfacial materials and all the peripheral materials are quite important, and combination with perovskite is of great importance. We have to work on architectures, processes, and to elaborate a highly efficient and highly stable real product. So that means to go to the module size. And we should do that, I think, in very close collaboration with the industry to elaborate a product that is compatible with them. So that means that to have very close collaboration with, for example, equipment manufacturer and end users to go in the right direction and to elaborate a real product that is compatible with this kind of production and PV production. So I think I will stop this here because this is the main point for us on the RTO side.
All right, thanks very much, Solène, for your viewpoint. I'll leave the floor to Chris Case from Oxford PV. Chris.
Hi there, and I may not try to take some of Solène's unused minute and a half, but you're probably aware that we're commencing manufacturing of our first product next year, a perovskite and silicon 2-terminal solar cell. And there's always a risk in being a first mover, but then again, someone has to do it. So 61 years after Shockley and Queisser gave us some workarounds to the PV solar cell efficiency barrier, it's clear that multi-junction solutions, the mainstay of space solar cells for decades, are no longer limited to exotic compound semiconductors, but can be achieved with the use of perovskite materials. So I like to think of perovskite as a poor person's gallium arsenide. And another observation from the week is evidence that many of the fears people had around reliability are being addressed. So we've seen many variants in the past week: 2T, 3T, 4T, even afternoon T architectures in different bottom cells. But I wanted to review our reasoning behind the choice of 2T perovskite and silicon. And we chose the path not because it was easy, but because we believed it represented the fastest way to introduce a new thin film material to the marketplace. And we could have looked at something other than silicon for the narrow gap, such as CIGS, but the silicon incumbent with 95% of the market was already lower cost than CIGS. So then the decision to choose a heterojunction bottom cell was also based on a view that the heterojunction would become broadly adopted in the future because of its simplicity and performance. And that's turned out to be a pretty good decision. It's easier for PV companies to fabricate solar modules when using familiar approaches. So it doesn't exclude other options such as Swift Solar's all perovskite or stacked and laminate solutions, but we believe that those will take more time to perfect. And the 2T cell requires no changes in electronics, stringing, or inverters or module assembly. And the simpler the concept and the fewer the barriers to adoption, the better. So he challenged the PV industry. It's a blend of risk aversion and capital paucity. So the buyers of large utility installations are not technologists, but financiers. You heard some of the comments about bankability from Radovan. You know, they wouldn't care if it was hamsters spinning mini generators in the field if the energy was cheap enough. Since the future of our planet is at stake, I urge that we all be bolder in trying out different solutions. I think our future is worth it. We're going to need 1,000 gigawatt PV factories going forward to deliver the needed 14 terawatts of PV to meet the 50% renewable targets in 2050. PV is already a US $200 billion business. It's hard to believe that the oil and gas industry still gets $500 billion in annual subsidies. And going forward, the future value of the industry is over $6 trillion US dollars. That's a lot of opportunities for people. So we got 9 people with varying views summarizing today, but I think we can all agree on one thing. The future is all electric.
Thanks very much, Chris. Thank you for your statement. Let's now welcome Gianluca Coletti from Soliance. Gianluca, if you will.
Thank you for the introduction, Roche. Yes, in 3 minutes, what is missing to make industrial application for tandem? Of course, I'm representing the RTO point of view as well. In here, our engine is spinning. We just need somebody that come and put the first gear, and then we go. Of course, we understand all the technical difficulties that are behind. We have seen in these 4 days. I'm not going to repeat myself on what is needed to get there. There are not only technical issues, there are non-technical related, very important issues. First of all, who's the customer, who's the end user? We discuss about bankability. Yes, the bank for sure. Also just the man on the street that want to have his own roof, possibly with tandem, because he give the higher energy yield. So it's always a question of market and available technology. I think perovskite had demonstrated in the past 10 years how you can get there. However, what had brought perovskite to what is today is not the same thing that will bring perovskite to the roof, in sense that the massive amount of research that everyone put is an example how you can get there with only few years. The same things need to apply on the industry. Now, of course, you would see competitors sitting together for that. Of course, that is very difficult. Radovan presented before what can happen with the front runner, where if this is a simplification, of course, but essentially you can have a demonstration, large field demonstration of a new technology, where essentially you are going to mitigate the risk. Because as in any new technology, tandem have to pass the valley of death. How can you make this valley of death pass? Personally, I think the combination of equipment supplier, final user, producer, making strong partnership for that, it's key in order to bring tandem into the market.
Thanks very much, Gianluca. Very loud and clear. Sebastian Gatz from Ardennes, would you be so kind as to take the floor now?
Sure, thanks. And I also applaud to the whole R&D community for this wonderful conference. I'm very encouraged about all these results and the understanding of the perovskites and the tandem technology. And therefore, I think it's now the time really to go for scaling and stabilization. And there are some people who drive this and already, but I think more and more has to follow this path. And there, from an equipment point of view, there are now 2 directions possible. That's in this way. So there are 2 success stories in the PV market, or I would say role models. The one is a PERC, and the other one is a cadmium telluride. So, and for us, it will be interesting how this will go forward. So, what was the success story for PERC? Everybody is doing more or less the same. So there was a clear roadmap for PERC, and therefore it could grow strongly and could be big. And that's my questions. Where's the roadmap for tandem? Where's the roadmap for perovskite? Or is it not possible? Is it too early? Is it too complex for having a roadmap to make general statements and also general predictions? Or are there too many IP secrets and everybody stick in the bubble and do not share IP? So that's a question, open question. And however, there's the other way, the cadmium telluride. Also here, it's a very good experience there. If the equipment manufacturer works closely with the R&D, the final producer of the end product, so these three people or three participants closely together, then it could be a success story. But there, you need a strong collaboration between all of these three parties to make it scalable and to make it a success story. And last topic I want to mention, it's now, I see a gap still between now very good lab results and going to fab. And there is reasonable investment to overcome this gap. And there must be big investment for this to choose the right technology to later on scale. And there, from our point of view, it must be a clear decision also from politicians and investors to close this gap. And there, it's not the right decision at this time to go for cheap. You must have a clear understanding of the technology and drive this to large scale.
Very interesting. Thanks very much, Sebastian. Very clear. Radovan Kopacek from ISC Constance. Radovan, would you be so kind as to step in?
So actually, I talked quite long about bankability, about bifaciality taking so long into the market, and I was actually quite frustrated that it took so long. But there were so many points actually to tackle, and it was not only that you open the rear side, we have additional energy yield from the yield side, but there were many things missing, like simulations and standardization, and this is, let's say, everything has to be done for tandemPV as well, and this is much more complicated. So I think we are just at the beginning of implementation of tandemPV, and I would also agree that the challenge is that there are so many solutions that not everybody is, let's say, working on the same topic, and this is what photovoltaic is about. It's about mass production, and it's about, let's say, one type of solar cells, which is PERC. And I mean, Chris mentioned that PERC came up very quickly into the market. That's not completely true, because PERC was out there already more or less for 30 years, and I was also working like 25 years ago on PERC. Maybe you can remember the laser-fired contact from Fraunhofer ISE. They had some ideas about it. And PERC came only because the Chinese just wanted to have PERC. And LONGi just put their very low-cost monocrystalline substrates. And from that point on, everything changed very quickly. But that was only from that point on. And China just decided to go. And that's the problem. So everything, PV is about mass production, and it's very risk aversive. And I think you had the same situation with concentrated photovoltaic. So everybody was working on their own solutions, and venture capital was flowing because you had other idea as a standard, and that's the problem. If photovoltaic is not working like this, you have to have big mass production. And maybe one last point I want to mention is we also are bringing new technologies into the market, and our Zebra technology, the very, let's say, the lowest cost IBC out there, and we are always compared with PERC, which we do not want to, but many people are saying Zebra is too expensive. It's not as low cost as PERC, because this is what people understand. It's only about the costs, and yeah, that's the problem.
Thanks very much, Radovan. Thanks very much. Thomas Leitens from Swift Solar. I leave it to you.
Thank you. Yeah, thanks. So in terms of what is missing and what's essential to move forward, I'm speaking from the standpoint of an early stage company, maybe a little different. I think there's the first one is capital to bridge a couple gaps that exist. One is the gap between academic research and forming a company. And I think that especially in the US, the previous iterations of thin film solar have really turned investors, both on venture capital as well as government, against any new thin film technology. And so that's been an ongoing hurdle for us, erasing the name, for example, Cylindra was really tough, is a difficult thing to fight against. So there needs to be capital to bridge that gap, to be able to actually form a company and do industrial research and start developing something. And then there's, of course, an even bigger gap that happens after that, which is the one that Chris is dealing with, I imagine, which is going from pilot production to mass production, which is, again, a huge influx of capital necessary. And certainly in the US, at least, there's not as much government support as I think there is in Europe at the moment for this technology. And so having a loan guarantee program, for example, from the government would be extremely helpful to help mitigate some of the risks associated with scaling up manufacturing or even deployment in the future. Then, so a second thing that needs to happen is a supply chain needs to be established, a large supply chain that we all can benefit from. It's a little bit scattered at the moment, and the quality control, as I said before, I think is not quite where it should be. I think probably most of us are doing a lot of that in-house. And that's supply chain. That's both in terms of materials, incoming materials, as well as, of course, tool vendors. And then the last is we need trust in the outdoor performance. And I would also say that we should be cautious. The worst thing that can happen is there's a bunch of perovskite modules out there and they all fail, and everybody's affected, right? So we should be careful in our approach, and we should be sure, and we should do a lot of as many accelerated tests and as many, and that's why these standards that we've all talked about are so important as well. So thank you.
Thank you very much, Thomas. Thank you very much. Olli Lundberg from Evolar AV. I'll leave the floor to you.
Thank you, Rock. Yeah, there is many important things my colleagues have brought up here previously. And I think it's not a single critical part which is missing. I'm also impressed by the research community, how far they have driven the small scale R&D, really keep pushing the efficiency limits. So I agree with the previous speakers that the really challenge now is to bring this to production compatible both processes and equipment. And I think this, even if it's nothing fundamental, but it takes time and a lot of work. Just imagine how much work has been put into the silicon technologies, millions of man hours. So I think we need to expect time and money will take to overbridge this gap to become a real production compatible technology. And especially, I think we have met this before with thin film technologies. It traditionally has a higher capex and lower material cost, but higher capex compared to silicon, which we now would like to combine our technology with. And then when you are sitting, even if you do your cost calculation, you can divide your capex by 8, and it's not so big number. But when the investor really sits there, it's much easier to choose maybe another PERC line or whatever with much lower investments. So I think the capex we really need to, as equipment suppliers, need to work on innovative tool and designs to bring the capex down for thin film coatings. Thank you.
Excellent. Thank you very much, Ole, for that. Lars Beck from IPVF Total. Can I leave you the floor?
Yes, hello everyone. I'd like to change a perspective maybe here a little bit and look at it from a customer's perspective. So if you're buying a PV product, what's missing? And as of today, I would say it's the convincing product that's missing. So far, we know that 3.5 multi-junction cells do exist, but they come at a rather high cost. So that's prohibitive for most of the applications, I would say. And for perovskites, obviously, we are just at the beginning of the long story, hopefully. So for a customer, you will always compare the new product to what is existing. And the PERC and heterojunction and IBC-based modules, they perform very well in their respective segments. And the cost reduction that we have seen was enormous over the last years. When I talk to my colleagues at Total, for example, and it's about utility scale projects, it's about industrial and commercial projects, they tell me it's all about cost. So you need to have a product for those applications that really can compete on an LCOE basis. So this, I think, is quite far out from where we are now with respect to tandem modules. Of course, there are specialty applications such as integrated PV. We heard about automotive. We hear about other proposals. But again, you need a convincing product that exceeds the current state of the art. You need to be able to integrate your product. It needs to deliver high efficiency. It needs to be stable. So I think from that point, we are still quite far away, and we need further development. Talking about that, I think what's missing then on the producer's side is the financing. I think some speakers have elaborated on the fact already that you do need a lot of money to come from a pilot line to industrial scale mass manufacturing. And you need to spend that money for a long period of time because your product will need time to penetrate the market, and it may not be cost effective in the first few years. So I think bridging this I think valley of death, as it was called beforehand, this will be very crucial. And I'm not sure how many companies will be able to make this. So I hope we'll see a good investment from interested parties here, because that kind of financing of the first production lines, scaling up the production so that you can benefit from economy of scale, this will be crucial for implementing these products in the market. Thank you.
Thank you very much, Lars, for that. And our last speaker is Stefan Röst from Eternal Sun. Stefan, if you will.
Thank you, and good afternoon, good morning, good evening, everyone. Yeah, as last one, I have a few maybe a bit more technical takeaways from my perspective on this conference the past days. Thank you to the organization for that. It was great content, a lot of very nice presentations. 3 takeaways for me. One, I think understanding the benefits of tandemPV on LCOE level requires really better understanding of the device power output, for example, in different operating conditions, like different temperatures, like Oxford presented with the temperature coefficients, different electrical loading, since perovskites do not have one IV curve, they're voltage dependent. Front and rear interaction in bifacial mode. So we just need to increase our understanding of all those real outdoor factors affecting performance of the devices in the field in real PV plants. Second takeaway, we are scaling up now to full-size modules, and we really need new test methods for the performance and stability there. We see that you need this cooling to 25 Celsius with continuous steady-state light instead of flashers. We always have been testing with flashers. We need to move to completely new types of testing methods. And that's just a lot of work, just a lot of effort in which we have to work together as industry. And I want to thank the many organizations here that work with us also on that. Quite not trivial and a lot of work to do still. That links to my third takeaway, to standardize these methods in work groups. For example, that IC work group on metastable devices. Yeah, please join those work groups. We need to start sharing more and standardizing more to get industry adoption and bankability. For example, just the PMAX test of those 10 devices needs at the end to standardize in some way so that we can compare apples to apples and make it bankable. So yeah, and of course we need to respect each other's core IPs on device stacks and materials, but we do need to share more to get some standardization. Because, for example, for bifacial, the standardization was really critical to define the LCE power yield benefits towards banks and investors and the financial institutions. So let's maybe close it off with that. Let's work together to bring this to the next level.
Thanks very much, Stefan. I would like to end here with special thanks to our speakers. Thank you very much. I hope it gave the audience a good overview of what is essential, what is missing for tandemPV industrial implementation. And I would like to thank the organization team for that fantastic workshop we've had this week. Congratulations for the great work. And again, all the best for the future. Thank you very much.